Good morning, students. I am Pramod Joy, your computer science teacher. And in this video, we are going to deal with the data handling. That's the topic number 3 from the unit number 2, CTP, Computational Thinking and Programming. So, shall we start? So, this chapter introduces data types, variables, operators, and expressions. Now, the data types. In Python, the data types can be mainly classified into four, and they are numbers, none, sequences, and mappings. Numbers. The numbers can be classified mainly into three: integer, floating point, complex. Sequences can be classified into three: string, list, and tuple. And mappings includes the dictionary. Or in other words, we can say that Python offers the following built-in core data types, and they are numbers, strings, list, tuple, and dictionary. Numbers. The numbers in Python have following core data types. Integers. It consists of integers and booleans. Floating point numbers. Complex numbers. Integers are whole numbers. They have no fractional parts. Boolean represent the truth values: false, which is equivalent to 0, and true, which is equivalent to 1. A number having fractional part is a floating point number. Fractional numbers can be written in two forms: fractional form and exponent notation. In Python, the floating point numbers have precision of 15 digits. Complex number is in the form of a plus bi, where I is the imaginary number equal to the square root of -1. Python represents complex numbers as a pair of floating point numbers. Examples are given below. Strings. A string data type let you hold string data. A Python string is a sequence of characters, and each character can be individually accessed using its index. The characters of the strings are given two-way indices: forward indexing and backward indexing. An example is given below. The index, also called the subscript, is the numbered position of a letter in the string. In Python, indices begin 0 onwards in forward direction and -1, -2, etc. in the backward direction. List. A list in Python represents a list of comma separated values of any data type between square brackets. An example is given below. Tuples. List which cannot be changed, called tuples. Tuples are represented as a list of comma separated values of any data type within parentheses. An example is given below. Values of type list are mutable, that means changeable. One can change or add or delete a list element. But the values of type tuple are immutable, non-changeable. Dictionary. Dictionary is an unordered set of comma-separated key value pairs within the left and the right curly braces, with the requirement that within a dictionary, no two keys can be the same. Example, vowels. In that, A, E, I, O, U represent the key, and 1, 2, 3, 4, 5 represent the values. Mutable and immutable types. The Python objects can be broadly categorized into two: mutable and immutable. The immutable types are those that can never change their value in place. Example, integers, floating point numbers, booleans, strings, and tuples. The mutable types are those whose value can be changed in place. Example, lists, dictionaries, sets, etc. Mutability means that in the same memory address, new value can be stored as and when you want. The types that do not support this property are immutable types. Variable internals. Python is an object-oriented language. Python calls every entity that stores any values or any type of data as an object. An object is an entity that has certain properties that exhibit a certain type of behavior. All data or values are referred to as object in Python. A variable is also an object that refers to a value. The type of an object. For example, A is equal to 4. What's the type of 4? That is integer. And what's the type of A? That is also integer. The value of an object. For example, A is equal to 4. Print 4. It will print 4 itself. Print A. That also will print the value 4. The ID of an object. The ID of an object is generally the memory location of the object. And ID is ID of 4. The memory location is given. Or the ID of A. The same memory location is given. Operators. The symbols or words that trigger the operation or action on data are called operators. Arithmetic operators. It includes addition, subtraction, multiplication, division, floor division, remainder, exponentiation. Unary operators. The operators that act on one operand are referred to as unary operators. Examples are unary plus and unary minus. Binary operators. Operators that act upon two operands are referred to as binary operators. Examples are plus, minus, into, division, etc. Floor division operator. The floor division is the division in which only the whole part of the result is given in the output and the fractional part is truncated. Example, A is equal to 15.9 and B is equal to 3. A divided by B, A slash B is equal to 5.3. A floor division B. That gives the answer 5 alone. Exponentiation operator. For exponentiation operator, 3 is equal to 64. That means 4 into 4 into 4. That is 64. Or we can say 4 raised to 3. Relational operators. Less than, greater than, less than or equal to, greater than or equal to, equivalent to, not equal to. Identity operators. There are two identity operators in Python. Is and is not. A is B returns true if both its operands are pointing to the same object. A is not B returns true if both its operands are pointing to different objects. For example, S1 is equal to ABC. S2 is equal to input enter a string. For that also we enter ABC. Now S1 is equivalent to S2. Yes, that is true. Whether S1 is S2, that is false. S1 is equivalent, S3 is equivalent to ABC. We are just assigning ABC to a new variable called S3. Now S1 is S3. Yes, that is true. In this slide, the precedence of the operators are given below. Expressions. An expression is any valid combination of operators, literals and variables. The expression in Python can be of any type given below. Arithmetic expression, relational expression, logical expression and string expression. Type conversion. There are two types of type conversions. Implicit conversion and explicit conversion. An implicit type conversion is a conversion performed by the compiler without programmer's intervention. An explicit type conversion is user-defined conversion that forces an expression to be of specific type. The explicit type conversion is also known as typecasting.